Now we will look at the accessories of the radiometer characterization suite, all of which can be used with both the DTMC 300 spectroradiometer and the DMC 150 spectroradiometer. The light source is the IL7 xenon source. This houses a 150 watt short arc xenon lamp with a condenser lens coupling light to the monochromator entrance port. The condenser lens position has been adjusted in factory and need not be changed. The source is attached to the entrance port using 4 M3 screws. To each side are weight-bearing feet with 3 screws. These should be loosened slightly to allow movement of the feet during installation of the source, and having installed the source securely, one should tighten these up to ensure that the load is being borne by the feet and not the slit. This source is operated from a 605 constant current power supply with red and black current inputs underneath the starter unit and a fan input equally. The 605 constant current power supply is used to operate both the IL7 xenon lamp and the CL6 calibration standard. And one should be very careful about the current setting. The xenon lamp operates at 8.5 amps. The irradiant standard operates at 6.3 amps. 6.3 amps here is no problem. 8.5 amps on the CL6 will result in lamp failure. The 605 current supply has 3 fixed settings and a variable setting with a key selector and an etched arrow indicating the current selected. We should rotate it to 8.5 amps, and I recommend removing slightly the key to ensure that we do not inadvertently change the current. The lamp is connected to the power supply using black and red cables, and the fan is connected using a 3-pin cable. When the source is powered on, the lamp failed light will illuminate for some short period during the time the starter circuits charge and the arc is established, after which it will extinguish, and on the front panel will no longer be seen the compliance of around minus 36 volts, but a voltage around minus 14 volts. And this voltage is merely for indication. The RSR unit is equally attached directly to the exit slit by M3 screws. There are 4 locations, but only the top 2 should be used because the bottom 2 are difficult to access. And having installed in place, one should adjust the position of the foot using a Allen key to slightly loosen the screw and setting the foot in location. The RSR unit is composed of a quartz lens which provides a 1-to-1 image of the exit slit aperture onto the detector under test, the reference diode or the radiometer under test. And there's a beam splitter, a quartz beam splitter. So light issued from the monochromator is instant upon the beam splitter. 15% of the light, or thereabouts, go to a monitor diode to the bottom of the unit, and the remainder goes to the reference diode or the radiometer under test. The monitor diode and the reference diode are both 10 by 10 millimeter silicon photodiodes. Use of the monitor diode ensures that any instabilities in the source during the operation period are removed by recording at all times the reference or radiometer response to the monitor diode response. A doubling in the lamp output, we'll see a double in the signal here, and here the ratio will be the same. The output of the reference and monitor diodes is a photocurrent which can be directly coupled to the detection electronics of both spectroradiometers. In the case of the DTMC 300 system, the signal is coupled by a BNC to BNC connectorized cable. In the case of the DMC 150 system, we have a BNC to SMA connectorized cable. In measuring radiometers, most of which will generate a voltage output, one should use the 472 module to interface to the detection electronics of the spectroradiometer. This unit has a power input provided by a transformer. It has an input which should be coupled from the device under test by a BNC to BNC cable, and one should then couple the detection electronics to a suitable output of the 472. There are three: 1 volt for 100 microamps, 1 volt for 10 microamps, and 1 volt for 1 microamp. One should note that the maximum voltage that the 472 unit can take is around 13 volts, and one should also note that the maximum photocurrent that can be measured by the detection electronics of the spectroradiometers is around 100 microamps. Therefore, if, for example, one has a source which generates a detector which generates in the vicinity of 1 volt, one should select not the first range, which will give 100 microamps, and saturate the detection electronics. When measuring radiometers, one can remove the 4 corners of the RSR unit to install plates for mounting Kippenzonen or Epley devices.